In part 1 of Lecture 4, we will answer the question, what is parsing? Before we start talking about parsing and grammars, we need to define a few terms. According to Webster's dictionary, parse is a verb meaning to resolve as a sentence into component parts of speech and to describe them grammatically. Grammar is a noun, the study of the classes of words, their inflections, and their functions and relations in the sentence. Syntax is also a noun, the way in which words are put together to form phrases, clauses, and sentences. In common usage, we tend to use the word grammar to reflect a more formal definition for how we put things together in a programming language, whereas syntax is used in a less formal sense. On the screen, what you see is a parse tree for the common typing sentence. The quick brown fox jumped over the lazy dogs. You'll notice that we break the sentence down into a subject phrase and a predicate. We break the predicate down into a verb phrase and an object phrase. The subject phrase has a definite article. It has two adjectives and a noun. The verb phrase has just a verb, although in many instances we could put an adverb in there too. The object phrase consists of a preposition, the word over. It has a definite article, in this case one adjective and a noun. You may wonder, why do we care so much about grammar? But the importance of grammar is that it also guides our understanding of the meaning of the sentence. We're talking about a specific fox. We know that the fox is both quick and brown. The action the fox will take is to jump. The object, not subject, but objects of the sentence are the lazy dogs, and the fox is jumping over them. We know that we're talking about a specific collection of dogs, and we know that these dogs are lazy. These are things that can all be picked out from parsing the sentence. In the previous example, we saw several things that we would expect to see in a grammar. We saw subject phrase, predicate, adjectives, and so on, all of which are non-terminals, aggregates of the various symbols that we'll have. We also saw terminals in the form of definite article, adjective, noun, verb. These cannot be broken down any further. A language is a set of sentences formed from the set of basic symbols. A grammar is a set of rules that govern how we determine if these sentences are part of the language or not. As we said before, the analysis is based purely on syntax. A syntactically correct sentence can be nonsensical. The example we see here is a group of trout were flying east, where they hunted down camels for their dinner. Now, we know very quickly we can figure out that this is actually nonsense. Trout do not fly east, west, north, or south. They don't hunt down camels, and they certainly don't eat camels either. However, the meaning is still conveyed by the syntax, even though the meaning is something that is totally not part of the world we live in. The parser takes tokens from the scanner as necessary and produces a parse tree, or analyzes the program as if it were producing one. We'll see that it actually will not do that most of the time. It is called as a procedure of the main program. In this case, we have a pointer to the structure of a parse node, and that would be for the root of the tree. And we can call it by parse tree equals parse. In most real cases, the parser actually returns a pointer to an abstract syntax tree or to some other intermediate representation of the program. Errors in programs are almost unavoidable. So it will become important that the parser will, or certainly should, spot any and all syntactic errors in the program. This requires us to consider how we will handle recovery from any errors encountered. We can consider any error fatal and point it out to the user immediately and terminate execution. We might also attempt to find a logical place within the program where we can resume parsing so that we can spot other potential errors as well. Given that this is a subject a little bit beyond the scope of the course, right now we will consider the strategy that we are going to consider any error fatal, and we will print an error message and terminate execution at that point. There are two different ways that parsers can work. Parsers can work top-down or bottom-up. Top-down parsers build the parse tree starting from the root, building it until all the tokens are associated with a leaf on the parse tree. In effect, what we are doing is traversing a parse tree pre-order as we are building it. Bottom-up parsers build the parse tree starting with the leaves, assembling tree fragments until eventually all the tree fragments are assembled into one complete parse tree. Here we see an example of a top-down parser. The parser starts with the token or terminal definite article, and from this we know it's a declaratory sentence where we have a subject phrase and a predicate. We know the subject phrase will have a definite article, possibly one or more adjectives, and then a noun. Top-down parsing assumes a certain minimum structure as we start building the parse tree. Bottom-up parsers take an entirely different approach. We will shift terminals, or tokens, onto the parse stack until we have everything that we need to build the tree fragment with a non-terminal at the root of the subtree. In this case, we will remove the definite article, adjectives, and nouns, and replace them with a tree fragment with subject phrase at the root. We will then do the same thing for verb phrase and object phrase. We will then reduce the verb phrase and object phrase into a subtree with predicate at the root. Then finally, we will reduce subject phrase and predicate into a sentence. Parsers can be either table-driven or handwritten. Table-driven parsers perform the parsing using a driver procedure and a table containing the pertinent information about the grammar. The table is usually generated by automated software tools called parser generators. Handwritten parsers are hand-coded, using the grammar as a guide for the various parsing procedures. While it can be easier in certain cases to write a handwritten parser, in the long run, we're usually better off with a table-driven parser. LL1 and LR1 parsers are table-driven parsers, which are top-down and bottom-up respectively. Recursive descent parsers are top-down, handwritten parsers. Operator precedence parsers are bottom-up, which are largely handwritten from parsing expressions.